Hello and good day, Algebra. We're continuing through Unit 2, the first of 5 rules for how to simplify exponent expressions. So if you look at what we're doing here, maybe some of you have experience with simplifying exponents before, but most of you probably not, okay? So this is going to be a unit, whereas last unit was kind of a lot of review. We talked about stuff you discussed before. Likely this is going to be new, okay? What does it mean to simplify something in the mathematical equation / expression context? We did talk about this last unit in PO7 when we had to simplify expressions before solving them.
To get to the smallest number as possible?
Sure, get to the shortest term, sometimes smallest number. What do we look to combine in last unit? PO7, CO6? Like terms, okay? And in this case, our like terms, so we're going to start this to combine like terms, okay? And in last unit, our like terms for equations were coefficients and constants. In this case, our like terms are coefficients and like bases. If you're wondering what a base is, look back in PO9 where we defined a coefficient, a base, an exponent, okay? So to combine like terms in our context here, it's going to be coefficients and like bases. Okay, so we'll do 3 of them together. We'll do more, but we'll kind of really hash out these 3 here and you can see what's going on here, because our goal is not to have to write it in expanded form every single time. Okay, right now our exponents are pretty small, manageable. You will get longer terms, larger expressions. You don't want to have to go that to expanded form every single time. But for now, that's where we'll start. So 3 to the 4th times 3. What's 3 to the 4th in expanded form? 3 to the 4th in expanded form. Lauren. 3 times 3 times 3 times 3. Right? And we're multiplying 3 to the 4th by another 3. Okay? So times 3. Right? How many 3's do we have in all? How can we write that 3 times 3 times 3 times 3 times 3 just as one term? John? 3 to the 5th power. There you go. You just simplified 3 to the 4th times 3. Okay? Let's look at the next one. 7y cubed. How does 7y cubed look in expanded form? 7y cubed. Expanded form. Oh, Lila. 7 times y times y times y. Only one 7, right? That coefficient is not affected by the power, but we do have that y times y times y. And how about y to the 4th? How do we write that in expanded form? What does that look like? Lauren? 4 y's, all being multiplied together. How can we rewrite that as one term? Take a look at what we have there. One term. Samara? No, not just 7 to the 7th. We only have one 7, but then 7y to the 7th. Yeah. Those 4 y's from our first term, 3 y's from the first term, and 4 y's from the second term can be combined. I mean, you can see this, right? Expanded form shows us we've got a total of 7 there. Okay? So 7y to the 7th power. The last one, 8x squared y squared, expanded form, what does it look like? 8x squared y squared. Connor.
8 times x times y.
Good. 8 and then 2 x's and 2 y's. Again, only one 8. It's a coefficient. Okay. And then how about 5x to the 4th y cubed? What does that look like? Lauren? Good. Okay. And so what we're looking for now is, I said in the definition, this is really the first time that we can see it here well. Combine like terms, coefficients and like bases. Because we're multiplying straight across here, there's no There's no addition anywhere, no subtraction. It's multiplication only. We can multiply things in any order. So I'm going to look at this and say, okay, I've got a coefficient of 8 here, a coefficient of 5 there. Even though they're not next to each other, I can multiply those. What do I get? Maybe 40, right? 8 times 5 is 40. Okay? And then the second part of our definition up on top here says like bases. I've got two different bases here. I have a base of x and a base of y. Even though they're not next to each other, I can look and see how many x's do I have in all. How many x's are all being multiplied together there? Sasha? 6 of them. So I can combine those to write x to the 6th. Right? And then my second base that I have here, I've got 2 y's there, 3 y's there. How many in all, Connor? 5 of them. So y to the 5th. So 8x squared y squared times 5x to the 4th y cubed can be combined to be 40 x to the 6th y to the 5th. Questions on what we've done so far? Because now we're going to take a look at this and say, okay, writing that out in expanded form is super fun. But if I look at some of the questions on the bottom of the page and the next page, I see my exponents get a lot bigger, my expressions get a lot larger, and this is going to be a lot harder to write it in expanded form every single time. So what shortcuts, what rules can you see? And down here, this is a key point. So all of these things that we're about to write down can go on a help sheet. What are you noticing happens? How do we combine coefficients? How do we combine exponents? What happens to the bases when we do this? Anybody see anything? Anything stand out? You can see it best in the third example there. It really, the rules for the coefficients, the exponents, and the bases are clearest in the third one. What do you see? Lala?
You multiply coefficients.
That is correct. Okay. Coefficients, when multiplying by the same base, are multiplied. Okay. Coefficients, when multiplying by the same base, are multiplied. And how do you know that you're multiplying by the same base here? How do you know that this rule that applies to this? Well, we can see the multiplication symbol here. Whenever you see that symbol, you know that you are multiplying by the same base, which is the rule for CO10. Okay? So coefficients are multiplied. Does that rule hold up in the second one? I mean, we started with a coefficient of 7. We ended with a coefficient of 7. What's the coefficient to that y to the 4th term? Even though it's not written. What's that coefficient to that y to the 4th term? Lauren? It's a 1. And 7 times 1 gives us 7. Okay? There were no coefficients in the first one because those 3's aren't coefficients, are they? Since they're attached to the power, what are those 3's? Look at your definitions from yesterday. What is attached to the power? The definition of this was literally attached to the power. The base. Okay? They are not coefficients. I can guarantee you, especially those who aren't really paying attention right now, I guarantee you that on the test, you're going to write 9 to the 5th. Guarantee it. Okay? I will put the naming rights to my 4th kid on that fact that someone was going to put 9 to the 5th on the test. Luckily, my wife doesn't watch these, so she won't ever know. Okay? But we don't multiply that 3 and 3 because they're not coefficients. They are bases. And this is why expanded form helps us out here, because we can see you've got 5 3's there. There aren't any 9's anywhere, right? But it's understanding that difference between a coefficient and a base, which is why PO9 was a PO. What about the powers? What happens to the exponents here? And this one you can see on all of them fairly well. But take a look at what we start with. Take a look at what we end with. What happened to those powers? Let's get someone new today. I've heard from you today already. Thank you. I mean, this is a power of 1, even though it's not written, right? So we start with 3 to the 4th times 3 to the 1st. We end with 3 to the 5th, okay? The second one, we have y cubed times y to the 4th. We end with y to the 7th. And the third one, with our x bases, we have 2 and 4. We end with 6. We have 2 y's and 3 y's. We end with 5. Sarah? They are added, okay? Exponents are added. All right? 3 to the 4th times 3 to the 1st. 4 plus 1 is 5. 7y cubed times 1y to the 4th. 3 plus 4 is 7. 8x squared, x to the 4th, x squared. 2 plus 4 is 6. Y squared times y cubed. 2 plus 3 is 5. Okay? This rule is actually quite helpful, right? Because like I said, when you look at what you've got coming up as far as from pretty big powers, rather than writing them all out like this, you just have to add them. Okay? And even though you are able to use a calculator on this test, simplifying this expression even with a calculator is not going to be very helpful, if you don't know what the rule is, right? And then how about those bases? Okay? What happened to our bases when we simplified here? We have a base of 3 and a base of 3. We enter with a base of 3. A base of y, a base of y. We enter with a base of y. Bases of x here, x down there, y down there. What happens to the bases? Leah? It stays the same. Nothing happens. Okay? Which again goes back to, well, I think green just, there we go. Okay. Which goes back to, again, why this is not 9 to the 5th. Those 3's being bases, nothing happens to them. They stay the same. They will still be a 3 in your answer. What changes is how many there are, right? Because we gained 1. Okay? Questions so far on this? Questions so far on this? Okay. Yes, Jacob. So the coefficient is the number that comes before a variable base. Like in 7y cubed, 7 would be the coefficient. And what's different from a coefficient than a base is that the coefficient is not affected by the power. There's only one 7 there. There are 3 y's. And so knowing what a coefficient and a base is, recognizing that 7 being a coefficient, you know this is not 7 times 7 times 7 times y times y times y, right? Because that power doesn't affect a coefficient. It also helps you with this rule because if I tell you, here, well, multiply the coefficients, it helps to know what the coefficients are. They're those numbers that come before the variable bases, meaning it's the 8 and the 5. And that's how we get the 40 there. Okay? And again, if you want to review that, you can flip back to P09. That's where we identified the coefficient, the bases, labeled them, wrote it out in expanded form, things like that. Right? Anything else? Anything else? Okay, let's go down the page a little bit, see what we have in store for us here. I'm going to rewrite what we did here just so in case you missed the notes, everyone's got it. The coefficients are multiplied, the exponents are added, and the base stays the same. Okay, first one, 6 squared times 6 cubed. I require you on this page to write each expression in expanded form first, just to help you avoid making that mistake of writing 36 to the 5th. No. Why is it not 36 to the 5th? John?
There's no 36.
There's no 36, right? Those are not coefficients. They do not get multiplied. When we write it out in expanded form, 6 squared is 6 times 6. 6 cubed is 6 times 6 times 6. What do you see? I see 5 6's that are all being multiplied together. 6 to the 5th. No 36's anywhere. So at the start, that's why expanded form is really helpful, especially when you're dealing with bases that are numbers. Okay, but let's go over to the next one, or the third one here. 14x times 10x to the fifth. Do we have coefficients here? We do. What are they? What are the coefficients here? Sarah? 10 is one of them. And what's the other one? Connor? 14. So according to our rule, we're supposed to multiply those, right? 14 times 10, since we're multiplying by 10, and we can just add a 0 on there, 14 times 10 is going to be 140. Cool. And now as far as our exponents are concerned, I've got an x to the fifth in my term on the right. What's my exponent, that 14x there? What's the power for that variable x? Sasha? It's a 1. So how many x's do I have in all? Fewer than a lot. I wouldn't classify this as a lot. Carly? 6. And we can see that by adding 1 and 5. As far as my base of x, my base doesn't change. That stays the same. And so this expression simplifies to be 140 x to the 6th. The 140 came from multiplying my coefficients, 14 and 10. The x to the 6th came from adding the exponents, 1 and 5. Since you do need to write this out in expanded form, you also need this part, 14 times x times 10 times 5x is here. And again, I'm having you do this just to confirm that your answer is what you see. What do you see here when written out in expanded form? A 14 times a 10, 140. I see 1, 2, 3, 4, 5, 6 x's, x to the 6th. Okay. Questions on this? As long as you can identify what a coefficient is and what powers are, and I mean, it's you just get that rule down. Any on this page you want to do together? Maggie? Oh, last. Okay. So let's start by writing this out in expanded form. We have 1/2 a to the 5th times 200 a squared. And again, you know you're using this multiplying by the same base rule because we can see that multiplication symbol there, right? And that's your hint that we're using this rule. So 1/2 times a to the 5th is 1/2 times a times a times a times a times a times 200, my second term now, my coefficient 200, and then a squared. So a times a. So I look at my rule and I say, okay, coefficients are multiplied. What are my coefficients here? I've got a coefficient of 1/2 and a coefficient of 200. What's half times 200? Or, because our brains can, half of 200. Jacob? 100. So that's going to be my coefficient in my answer. And then expanded form allows me just to count all these a's up, but I can also use our rule to add the powers. 5 plus 2, that's going to be a to the 7th. So 100 a to the 7th is my answer. So again, if you forget expanded form, or if you forget the rule, you've got expanded form to fall back on. It takes longer. It's not as efficient. It's just multiplying and adding, but you can see what you got. Any others on this page you want to go over? John? Okay, negative 8y times negative 2x cubed. Let's start by going to expanded form. Negative 8 times y is negative 8y. And we're multiplying that by negative 2x cubed. So a coefficient of negative 2. And then x times x times x. Good so far? Okay. So to simplify, we're looking to combine coefficients and like bases. What are my coefficients here? What are my coefficients here? John? Negative 8 and negative 2. They get multiplied, and negative 8 times a negative 2 is a positive 16. Okay. Now I look for any like bases. I can't combine my x's with my y because they're not like bases. So really, there's not much else I can do here. I only have my x cubed. I've got 3 x's. I've got 1 y. So 16 x cubed y. Would it be wrong if you put it 16 y x cubed? I would not mark that wrong. It's not technically standard form, but right now I'm not focused on that. I want you to get the rule down. Any others from this page? No? All right. Let's look at the second page then, where you don't need to write it in expanded form any longer. The goal here is to use the rule instead, which is helpful for you because you see you've got exponents of like 10. There's 11 there. This one's got 2 different bases with 10 and a 13. That's no fun to write out in expanded form. So, any you want to talk about from this page? Save the very last row. We'll get to that in a second. But any of these, looks like 12 of them that you want to go over. Leah. First one, third row, that 8x squared y. Yeah? Okay. So looking at it expanded form, what? Well, first one, second row. 6n to the 10th times 9n squared? Okay. So looking at expanded form, we could write it out that way. Okay. But using the rule, what are our coefficients here? Lila.
6 and 9.
What's 6 times 9?
54.
54. By looking for our coefficients and multiplying them, as the rule states we can do, we get a coefficient in our answer of 54. Okay. Now we look for our like bases, which we do have like bases of n here. We know that n isn't going to change. That n stays the same. But what is our exponent going to be? N to the 10th times n squared. What's the exponent going to be in our answer here? Leah? 12. Yep. And we get that by adding those powers. 10 plus 2. There you go. 54n to the 12th. Like I said, as long as you can see what is my coefficient, what are my powers, if you know the rule, the math part isn't the difficult part. 6 times 9, 10 plus 2, the math part isn't the hard part here. It's knowing what to do and when. Others you want to talk about? Aiden.
The last one on the third row.
Sure. 8x to the 5th y squared times negative 7x to the 10th y to the 13th. First of all, coefficients. Do we have any? And what are they? John? 8 and negative 7. What do they multiply to be? 8 times negative 7. Anybody? Good. Negative 56. Okay. Now we look for like bases. I've got like bases of x and like bases of y. So I will have an x term. I'll also have a y term. So I can't combine them together, right? I can combine all my x's and all my y's, but not x and y together. They're not like bases. What's the exponent going to be above my base of x? Carly? 15. 5 plus 10. What's my exponent going to be above my base of y? Jacob? 15 again. 2 plus 13. There you go. Okay. Any others? Yvonne? Third one, third row. 7x cubed times 4x squared y to the 9th times 2x to the 5th y cubed. So in this case, we have 3 terms, right? So we have the potential for 3 coefficients, which we actually have. We've got a coefficient of 7, a coefficient of 4, and a coefficient of 2. All 3 of them get multiplied. So you can do it in any order. 7 times 4 times 2, 2 times 4 times 7, 7 times 2 times 4. It doesn't make a difference. But those 3 coefficients multiplied together give us, Lila, 56. Okay? We only have two bases though, right? We've got some x's, we've got some y's. The question is how many x's and how many y's? What exponent do I put above my x base? Take a look at it. We got 3 in the first term, x cubed. We have an x squared in the second term, so that's 2 more. X to the fifth in the third term, that's 5 more. Ifan? 10. A total of 10. 3 plus 2 plus 5. Then for my base of y, I don't have any in the first term, but I've got 9 in the second, 3 in the third. What is that a total of? Carly? 12. So my simplified expression is 56, x to the 10th, y to 12. Okay. One thing I'm going to remind you of, this tends to trip people up as well. When you only have a base without an exponent written, it doesn't mean that it doesn't have a power. We just don't write it because it's a 1. So make sure you do think of that as n to the first when you do your rule for that one. Or for this one, this is a y to the first. Okay. Down at the bottom, we kind of do a equation solving with this rule here. It says fill in the missing exponent. N to the blank times n to the fifth equals n to the 11th. What would this have to be so that if I multiply by n to the fifth, gives me a total of 11 n's? G. 6. Good. Okay. The next one, I have a total of 10 x's. I've got 7 in my first term. How many would have to be in my second term? I've got a total of 21 y's. I've got 4 in my second term. How many would have to be in my first term? The next one, I've got a total of 38 y's. I've got 7, 3, and 12 accounted for. What would that missing power need to be? And lastly, I finish with n to the 9th. I already have n to the 8th and n to the 5th. Think about it. What would that missing power need to be to bring me back to 9? Okay, and we'll talk about that on Monday when this is due, because tomorrow is a retake day. So if you have practice work, get that to me. If you don't have practice work to work on, make sure your Khan Academy is done for tonight. Okay, I'll repeat that. Khan Academy done tonight. Football sheet is due. Math packet to work on. Lots of stuff. All right, folks, homework due Monday. That is how you math.